Let's just say that's the roller at the end there. The roller's round. This is a round, rotating, spinning roller. The conveyor belt runs across the roller. The weight of the belt drives the roller. So this is turning like that all the time. Okay, so the conveyor belt runs across. Once that seizes, jams, the bearing will seize. Bearing seizes, that conveyor belt is rubbing. Rubs like this. So rubber running across steel after a couple of weeks wears through the surface. So it wears down. So I wear away the belt and now I've cut off this top section. So along this edge here...
So that belt will wear away that.
Yeah. See, this belt is in a mining situation. Dust and dirt sits on the belt. It's an abrasive. The belt, rubber is an abrasive when it rubs across the surface over enough time.
So it's like a sanding belt.
Yeah, yeah. Very much the case. So once that sanding belt wears through the surface, this edge here is developed. That's a knife edge, literally. You'll cut your finger on how sharp it is. And once that knife edge develops, you've got two scenarios that could happen. May not, but could, because opportunity is there. Now chance comes into play. Yeah? And is this my unlucky day or is it my lucky day?
Well, how do they know
if a bearing is seized up?
You can go and touch it.
But don't they have miles of this? That it's kind of inaccessible?
Look, not what they do, they get a thermography camera. They get a thermography camera and they walk the conveyor. Walk the conveyor and look for hot spots, look for hot bearings.
And that's the best they can do, I mean.
Well, there are so many of them, there are so many kilometres of these belts. It's the easiest and quickest way to do it. Let the thing fail, let the thing seize on purpose, because you won't know it's a problem until it actually seizes. And most of these rollers are trouble-free for a long time. Most of them. Every now and again, they're not. So to go and test every single roller to find the one in 2,000 that's a problem, it's very expensive. Quickest way is to get your thermography camera out, and in fact, you can almost drive down the conveyor line. You know, in a car, you just drive down slowly looking for the hot spots. It's not difficult to do these days. Or when it's really bad, you walk the conveyor system and listen for the squeal, because it'll squeal like a lot of noise.
Does it lose lubricant or what?
I've never gone into the reasons why. There would be reasons. Poor fitting, badly fitted, lubrication problems, yeah, all those things of bearings come into play. Maybe underloaded bearing, they've got a wrong choice of selection for bearing. Any bearing failure factors would be issues here. But the consequence is massive. Yeah? $2 million because I didn't bother fixing this when I had plenty of time to fix it. So yeah, we want to paint the picture. And I've got to be honest here, in my career now I've heard of this happening, a complete system being burnt down twice. In my whole career I've only ever heard it happening twice. It doesn't happen very often, but it can happen. Torn belts are regular. In a mining game, ripped belts, the full length, very, very common. As in every month somebody in Australia, well, many companies in Australia would have a torn belt.
They have to replace the entire belt?
Stop the system, unload the conveyor, get out there and either, if the tear isn't too long, they'll cut that section out and splice in a new bit of conveyor. If the whole conveyor is torn, all 2 kilometres are torn, for example, or whatever the distance is, we've got to replace the whole belt.
How about just having stages of belts in series, so you don't have to replace 2 kilometres, you just replace a shorter?
That would have been looked at, I'm sure. That 2 kilometres, I guess, is certainly an extreme length. Often around a couple of 100 metres, half a kilometre. But yeah, they would have, that's where the guys at the design stage, when it's still a drawing on the drawing board, should have gone through the optimisation loop we saw yesterday. We should have thought about, gee, this will happen. Torn belts will happen. How do we minimise the cost?
They felt they'd introduced too much risk. You got all the more drives.
Look, I mean, yeah, that's the whole game we're playing. How do you minimise that risk right down to what we're willing to live with? And when it goes against us, stop bitching about it. You made that choice and it's gone against us. So just pay the money and get on with it. Yeah, but I want to understand that risk on the drawing board. I don't want to build this plant and then find, you know what, that conveyor is 2 kilometres long. It'll cost me $1 million each time the belt goes down. Let's put in 3 or 4 conveyors. Let's cut down to half-kilometre conveyors and that'll minimise my cost. That's a design choice that should have been made on the drawing board before the design was approved to be installed. That's how I read it. So yeah, our risk equation, important stuff, because when something goes wrong, that consequence is a given. I'm going to lose that much money depending upon the incident. All I can play with is opportunity. Have no opportunity for things to go wrong, because when opportunity is there, all I've got left is chance. The dice roll out of my control, and how they turn up, I've got to live with it. So what we want to work with is these two factors. Never let your conveyor rollers develop a knife edge. Simple rule. If you can't get to it immediately, well then monitor this on a regular basis. Go by there every day if you need to and have a look. How quickly is this wearing away? You know, keep the flag raised high. This is high risk, guys. We're playing with danger here, playing with $2 million down the drain if the dice roll the wrong way.